Alright, so I'm going to talk a little bit about photoelectric sensors. This is just a photoelectric sensor from SICK. Basically we call this a proximity mode, where when you detect an object, it'll just trigger. So right now I'm looking down at the table. If you're looking at this red indicator light on the power supply, I have the output tied into Q1. Q is just a symbol for the output. One thing to remember when you're wiring these sensors is to remember brown is hot, blue is not. And what I mean by that is the brown wire is the supply voltage and the blue wire is your ground or common. So brown is hot, blue is not. The way I remember that is when you're cold, your skin turns blue, so blue is not hot. So anyway, I'm not in range of the table, so my red indicator light is on. As soon as I come into range, you can see that light turn off, so it switches states. So we back up, we go to range, we come forward, we come into range. With this kind of sensor, we're just purely based off the amount of light that we get back. They use a standard M12 4-pin connector. It's an industry standard, very common. M12 for the M12 threads involved in the connector. So we have different types, and there are different ways to wire these things. Actually, you see right now I'm not in range, so the light's on. I'm in range, the light is off. Well, we have an extra wire here, the white wire. If I wire that to the supply voltage, so I'm just tying them together, you'll notice that I'm out of range, and the light is off. Come into range, and the light turns on. So I reverse the logic based on this pinout. The white is a control wire to reverse the logic of the output. A lot of these have different teach buttons or potentiometers to adjust the range. So what you can do here is adjust the sensitivity of the sensor. I can get the... So right now I'm not triggered. I'm going to do this so it's easier for me. So I turn this clockwise. You can see that I came into range, so I'm going to back it up a little bit further. I think this one should have enough range. Okay. So I'm not in range, but I'm going to turn this clockwise to turn up the gain, and now I am. So this is just one type. We have some that will only trigger on a reflector. We have some that will require a receiver sensor. With these proximity modes, there's actually a sender and receiver lens, so you don't need a separate sensor. So just like this one, comes out of range, in range, out of range, in range. And so typically you'll see these on Ford assembly lines where they need to detect a part coming down a conveyor and they want to trigger and perform a certain action. Where it really gets into the technology is trying to see one thing but ignore something in the background. So again, if you want to adjust this sensor, right now I'm out of range, for example. So if I turn the pot, now I'm in range. So I'm in range. If I turn it counterclockwise, reducing the sensitivity, the light turns off. So it's pretty simple. All these operate on, not all of them I should say, but most of them operate on 10 to 30 volts DC. You can apply anything. We have different types, NPN or PNP transistor types. Stick with PNP. It's really easy. It's the most common in America. Essentially what a PNP transistor does, if you supply 12 volts DC, your output's going to be 12 volts minus whatever power it takes to consume to power the sensor. So you give it 12, you're probably going to get 11 volts to trigger some action. So on the other ones, I don't know if you could see it, but there was a red light spot from the sensor. You'll notice that this one here, you can't see anything. So, but it's working. You can see how the light is triggering on and off. This one's an infrared sensor, so it's invisible light. you can't see it with your eyes. So in applications where a customer doesn't want this annoying light spot, or maybe there are people around, they like to go with infrared. Or in applications where they want the sensor to be hidden, infrared is preferred. So we have all different types. I mean, these are some of our, this guy is die-cast zinc, so it's really strong. We have plastic housings. We have some that are Teflon coated stainless steel. Just depends on the application and price point for the sensor, or for the customer. So yeah, it's pretty easy. Plug it in and adjust it. You're done.
Say Go Storm.
Go Storm, Sauk Rapids Rice. Kicks our tails butt.